It came from another star older than the Sun, faster than any comet we've ever known, moving at 58 kilometers per second, slicing through the dark with a precision that feels deliberate. Its orbit tilts at 175 degrees, almost the same plane as Earth. Out of every possible angle in the sky, it chose ours. Some call it a comet, but comets don't turn green against the Sun. Its tail points the wrong way toward the light, as if defying everything we thought we knew. And in that strange emerald glow lies a secret carbon dioxide overpowering water, nickel without iron chemistry that doesn't belong here. If this is only ice and dust, why does it move like it remembers something? This is not just ice. This is 3I Atlas. First seen on July 1st, 2025. A faint dot of motion caught by Darrell Seligman and the Atlas survey. The asteroid terrestrial impact, last alert system. Each night, their telescopes sweep the heavens for fragments, wanderers, ghosts of stone, but that night, something else crossed their view. A traveler, a streak of light cutting through the background stars at impossible speed, unbound by the Sun's gravity, untouched by any planetary family. For millions, maybe billions of years, this fragment of another star drifted between suns, a silent ember from a foreign sky, crossing the dark to reach us. The universe is sending these gifts to our doorstep. All we have to do is open them. So what message hides inside a story older than the Sun, arriving right on time? The interstellar visitor entered the solar system like a blade through silk fast, precise, unstoppable, moving at 58 kilometers per second. This traveler raced beyond the Sun's own escape velocity, too swift to be captured, born only to pass through. Its orbit slices the solar system at an angle of 175 degrees, almost the same plane as Earth's, separated by barely 5. Out of every possible path in the sky, this wanderer chose ours. The first visitor, oh moi, was just 400 meters long and drifted at 26 kilometers per second. The second, Borisov, nearly a kilometer wide, moved faster, 32 kilometers per second, but the newcomer, 3I Atlas, dwarfs them both nearly 7 kilometers across, tearing through space at 58 kilometers per second, the fastest, the boldest, the strangest of them all. A blade of motion grazing the solar system's skin, and for a moment, we can feel the cut. Astronomers estimate the interstellar guess spans between 5 and 10 kilometers across a mountain of frozen time, drifting through the dark. The traveler turns once every 16 hours and 47 minutes, steady and unhurried, the rhythm of something that has never known haste. Across its ancient skin lies a muted crimson hue, the mark of D-type asteroids, the same tone found in the Tagish Lake meteorite that fell over Canada a century ago. Light glides over the curved surface not in flickers, but in slow pulses, like breathing. Every rotation, a billion-year inhale, a sphere of memory turning beneath alien sunlight. Long before discovery, the Vera Rubin Observatory had already captured 37 silent frames of the Wanderer sliding through its test images. At the same time, NASA's test mission built to hunt for exoplanets watched the same region of sky from May 7th to June 2nd. During that quiet window, the ancient fragment was already shedding gas and dust. 6 astronomical units from the Sun behaving like a comet long before its name was known. The traveler was already whispering through our telescopes before we even knew it existed. A secret crossing of light hidden in plain sight. When astronomers turned their spectroscopes toward the traveler, The results were startling. Carbon dioxide overwhelmed water vapor at a ratio of 7.6 to 1, the highest ever recorded in any comet. The nucleus was bleeding gas and dust between 12 and 120 kilograms every second, as if exhaling secrets from a frozen heart. Spectral revealed traces of nickel, but no iron, a chemistry that doesn't belong to our solar system, and within that emerald haze, a faint fingerprint of cyanide, the same molecule that terrified the world in 1910 when Halley's Comet passed close to Earth. A century ago, cyanide made the world afraid. Now it makes us curious. Some believe the traveler was born near the carbon dioxide frost line of another star, a place where even gas refuses to melt. Maybe it's breathing in a chemistry we've never met. Then came the strangest discovery of all, a tail that pointed the wrong way. Instead of stretching away from the sun, the stream of dust arched toward it, an anti-tail, defying everything we thought we knew. The phenomenon happens when sunlight heats the comet's day side, releasing particles that drift sunward, while the solar wind is still too weak to push them back. Even shadows can face the light. Every major eye on Earth, from Chile to Hawaii, turned to watch the impossible geometry unfold. Was it geometry or something more? Poll prompt. Type A for geometry, type B for outgassing. Let's see what you believe. As the interstellar guest continues its journey, astronomers open what they call the watch window, a set of checkpoints to trace its behavior across the solar system. 4 markers, 4 chances to catch the mystery in motion, 1 brightness change. If the magnitude shifts by more than 1 point, something inside is stirring. 2 trajectory shift. Any deviation beyond 0.05 degrees could mean a jet, or something we don't yet understand. 3 jet morphology. Does the tail flip from anti to normal, or does it defy sunlight again? 4 spectral ratio carbon dioxide to water. If that balance shifts, the chemistry of the traveler itself is changing. Checkpoints across time. Mars at 0.1, 9 astronomical units. Venus at 0.65, Earth at 1.8, and finally, Jupiter at 0.36. If any of these change, the mystery deepens. Type 1" the comments. If you want weekly watch window updates, we'll watch the sky together. When scientists traced the path of the traveler backward, it led to the thick disk of the Milky Way, an ancient region rich in old stars and poor in metal. Over 10 million years of travel, the wanderer brushed past 93 different stars, but each encounter changed its speed by less than half a meter per second. That means its story began long before ours, between 3 and 11 billion years ago. When our own sun was still dust and silence, everything we know was born 4.5 billion years ago. This one was ancient, when our sun was still dust. Somewhere out there, in the thick disk's dim light, a small fragment broke free and began a journey no one was meant to witness. A billion years later, that same fragment passes before our eyes, a whisper from a time before time. In science, discovery isn't just about what we see, it's about what survives the climb. Every anomaly, every strange signal, must climb what researchers call the ladder of evidence. The first rung, repeatability. Can another telescope see the same thing again? The second, multiband proof. Does the signal appear in more than one wavelength, infrared, optical, or polarimetric? The third, dynamic geometry. Does its motion obey gravity or rewrite it? And finally, intent. The hardest to reach. Is there a pattern, a purpose, or only chance. Every anomaly must climb the ladder from noise to meaning. Knowledge isn't a spark, it's an ascent. On October 3rd, the traveler brushed past Mars, just 0.19 astronomical units away. Rovers on the ground and orbiters in the sky were ready until the government shutdown froze every screen. Still, one scientist refused to wait. Simeon Schmaus downloaded the raw frames from NASA's Perseverance rover and checked each one by hand. Hour after hour, pixel by pixel. He stacked them together until a faint streak appeared, the ghost of Atlas crossing the Martian sky. Then, silence. No music, only the soft click of confirmation. In science, caution can look like silence. But sometimes, silence is the sound of truth arriving. Every mystery invites a theory, and some theories reach far beyond science. Astrophysicist Avi Loeb proposed that the traveler might not be natural at all, giving it a 30 to 40% chance of being alien technology. He listed 9 anomalies, 5 that science can explain, and 4 that remain untouched by logic. But extraordinary claims demand extraordinary proof. Astronomer James Davenport offered a checklist 4 pillars that could reveal the truth. Trajectory. Does the object slow down or change course unnaturally? Spectra. Do its colors match metal? Carbon fiber, or something no comet could produce? Shape. Is it a sphere, a shard, or a machine? Signal. Does it whisper in radio, or speak in silence? On the scorecard of evidence, the traveler still hovers between wonder and uncertainty. Belief is easy. Proof is art. The lessons of 3i Atlas go beyond its data. They remind us how small we are, and how vast curiosity can be. Spacecraft across the solar system are already watching. The JOICE mission will soon pass through the edge of its tail. NASA's Juno will glimpse the traveler as it fades near Jupiter. The European Space Agency's Comet Interceptor, launching in 2029, will wait in deep space for the next interstellar visitor. And the Southwest Research Institute, led by Alan Stern, the mind behind New Horizons, is already designing a probe that could one day chase one down. It's teaching us what our textbooks never could, that the universe still holds surprises beyond imagination. And the best is yet to come. Maybe it's just ice and dust. Or maybe a mirror reflecting how little we understand. We spend our lives searching for answers, yet the universe speaks in light, not in words. When the next traveler arrives, we'll be ready not to explain too quickly, but to listen, because sometimes the light doesn't need translation. When the next light arrives, we'll listen before we speak. Subscribe to keep your watch window open.